Great, I can see everyone is trickling in now. Right, so good morning and welcome back to the NZRSE conference for 2024. We are in for another day of presentations, lightning talks and networking, and we'll begin with our keynote for the day, Dr. Erin Kwon, at 9:40 a.m. But before that, I would like to reiterate a few tips for making the most of this online platform. If you are having any technical issues, you can click on the red live support button at any time, and that's located at the top right corner of your screen. I'd also like to point out the recordings of the previous sessions will be accessible in the NZRSE platform once this conference is over, and some from yesterday are already uploaded in there. You can see these by clicking on the past sessions on your timeline, and you'll be able to find a link for that session recording. I'd also like to remind you that you can chat with the other attendees and presenters in the meeting hub, which you can access on the right-hand side of your timeline. And just a reminder of the code of conduct and to make yourself aware of the program, which is on the website or on the platform that we are using. Another reminder that this afternoon's BOF session is actually on a Zoom link, which is on the portal for this afternoon. So you'll be able to jump onto that, and I just ask that you make sure that your Zoom settings are all good to go, just so that you don't miss any of the beginning of that session. There isn't actually too much more for me to say, so I will hand over to Maxine shortly. We're not due to start until 9:40, and I am aware that people are running to the conference schedule, so we will just wait until that time before we bring everyone else into that. So time now to make yourself a cup of tea or a coffee, and we will see you at 9:40.
Kia ora koutou, and welcome to the second keynote of the NZRSE 2024 conference. I'm Maxime Rio, and I'll be chairing this session. And this is my great pleasure, my honor, to introduce Dr. Erin Kwon from the Matai Medical Research Institute. She's a senior research fellow at the Matai Medical Research Institute, leading the concussion research program, where they seek to improve the understanding and treatment of mild traumatic brain injuries, or MTBI, and also known as concussion. But before that, let's go back in time a little bit to say that Erin earned a combined Bachelor of Engineering and Science, that's the combination, degree at the University of Auckland, with majors in biomedical engineering, physics, and chemistry. That was followed by a master's degree in mechanical engineering, focusing on forensic modeling. And she pursued the research in forensic modeling with a PhD for her work on anatomically realistic physical and computational models of cranial ballistic impact and associated back spatter. A fascinating read, but I may not recommend all the pictures for everyone. And she looked at how a blood spatter from gunshot wounds can be analyzed to help forensic investigators to link patterns at crime scenes to specific events. Maybe it's only me, but I see a link with the previous keynote speaker there. And before leaving the stage to Erin, I just want to bring some personal connections I have with her. So I had the chance to work with Erin in the past years, and I met her about 4 years ago when the Matai Institute was starting its journey. And at that time, Erin was looking at connecting her people with the rest of the Aotearoa e-science sector. And when I mean connecting, sometimes it was quite literally. So I was sitting in a meeting with her and some broadband providers just to find a way to have a good connectivity between the Gisborne Institute and Auckland and the rest of the country. And as part of this journey, at least what I've seen from my collaboration and work with Erin, she was looking for software engineering and computational resources. But what was very great is she was not looking for one one-way interaction, but it was always a sharing experience. And she was always very patient in explaining her research context and her constraints and the medical context too. And she has a genuine interest in understanding what the other people, the services, what they could offer and what were their context they were operating in. And so that was a really rich experience. So I would like to add that on top of her great scientific skills, she's really an enabler in the community, in her community, but in the larger RSE community, I believe. And it's really nice to have her today for us. Final word, just a quick reminder, do not hesitate to post any questions or comments you have during the keynote. We'll take them at the end of the keynote. And I think that's all I needed to say. So on this, Erin, the stage is yours.
Pai, tēnā koutou katoa, ka whakapapa au ki South Korea. Engari I tipu au ki te whenua o Aotearoa. Ko tai rāwhiti e tamaki makaro te wāhi kāinga, e paiwai rangahau mato au I mātai e ABI. Ko Erin toko ingoa, tēnā tātou katoa. Kia ora all. I think Maxime almost did my keynote speech for me. It was very embarrassing, but I checked with a professional, a statistician last night, that in theory, that because Andrew did such a fantastic job yesterday for his keynote, on average, the keynotes for this conference will be great no matter what I do. So I'll be taking on a bit of a lighter things. I'd like to mix with the jokes. I had a mixed response to my jokes, whether that was funny or not funny. So let me know. It is my honor and delight to be invited to speak at my favorite conference. Like, I say that without any reservation, and I'll show you why. Because this is the only conference that lets me do this. This is how I was participating in the conference yesterday. Yep. Other than the physical comfort, I was learning a great research tools, what's out there, new technology, and just enjoying the community and how supportive everybody is towards the research goal. Very impressive. And we need every single bit of help down in Gisborne here. In Gisborne, I started working at Matai when we first opened our doors for medical imaging research. In 2020, as Maxime said, we made our MR technicians live in a container with the MRI for about 4 years until we finished our beautiful new building April this year. We had a lot of support, some people just coming and congratulating and participating in our opening event. And if you want to pop by and pay a visit, just let us know and we welcome everybody. This was my first postdoc position jointly appointed between Matai and University of Auckland, and I'm still here. I'm quite happy. This Matai was set up as a regional research institute to bring closer to people who may not have access to these advanced imaging otherwise. There are distinct pros and cons of working in a regional research facility. I think I'm qualified to speak about this because I work both in Auckland and Gisborne. The best advantage is because we're small and nimble, anything you do makes a large impact. You can see how your actions or plans ripple and get a live feedback quite easily, and it's great. Second, it has a nice view. During the COVID, I really enjoyed my beach walks and all the things. And when I was walking by this statue of Captain Cook, Chris Hickens was telling everybody to spread their legs. So to me, that's a spread your leg statue. From the other side, that beach looks like that on a good day. That's where the statue is. And we have multiple of these beaches and good surf. Some of my colleagues actually take their lunchtime, if the tide is right, and go for a swim. For an introvert like me, less people is a great pro. And that everything is a 10-minute drive away. My Auckland friends ask me, how far is the airport? How far is the grocery? How far is your work? And my answer is always 10 minutes, 10 minutes, and 10 minutes. However, there's some cons coming with the regional research. We do suffer from infrastructure. The power delivery here is very unstable. If a car runs through a power line in the gorge, we might lose power for days. And in last extreme weather events like the 2022 cyclone, the whole township lost power and even a phone internet lines for more than a week. And with the MRI, who has a very peculiar requirement to chill helium to super cool temperature, that was a very nerve-wracking moment. Second thing is you have to fly through Auckland or Wellington to get to anywhere. I've just been to the Queenstown Research Conference last week, and it felt like a bit of a ticket tour to go to Auckland, to go to Queenstown from Gisborne. But last negative stuff is anything you do make a large impact. So you have to really think about what you're doing. Okay, so a bit more about our institute. While our most loved research equipment is our coffee machine, there's no dispute about that. The most expensive equipment is MRI. The machine alone costs millions of dollars. MRI has been one of the most inequitable technology. I'm hoping that you can actually notice that the higher colored countries are not the worst off financially countries. That's not only due to the cost of the machine, the personnel, upkeep, like chilling the helium alone, it costs us thousands of dollars in electric bill just to keep the cold head cold. So they all pile up eventually. There are international movements to make the imaging resource more accessible to the inequitable area, but that's still in the research realm and not in the public realm just yet. Previously, Gisborne had a 1.5 Tesla MRI in the hospital. What does it mean? If you need a cardiac surgery planning or bypass or something that needs a bit more detail and oomph, you have to get a 3 Tesla scan, and your next stop is Hamilton. With medical condition, you'll have to find somebody to drive you to Hamilton, probably spend the night there, and then drive back. That was a lot of logistics cost and time and burden to your family too. Matai operates a 3 Tesla MRI, which is on par with any other top-notch research machines around in New Zealand and Australia or world. We open our MRI time for clinical scans when there is no research scans planned, so we can serve the region and the people have better, easier access to imaging resources that they need clinically. So in Matai, we joke about the MRI to traffic light set ratio in this town is 2-to-1. We have 2 MRI, one from a hospital and one from us, 1 set of traffic light. Stats look really great, doesn't it? However, let's look at the MRI per million capita statistics from World Health Organization. New Zealand is about sitting at 15, 16 MRIs per million. How does that rank against other countries? I made sure I grabbed the one below us, just so our cousins get a perspective. Even without Matai, Gisborne was doing pretty well. The hospital MRI was serving the about 55,000 capita and catchment. But when we came in with a 3 Tesla machine, the statistics improved drastically, 38 MRIs per million, which is better than Germany. We're looking to add our second research MRI, which will push it to 57 per million, making this region better than Japan. So that feels good, right? When I heard this year's conference theme is empowering communities through research software, like I personally relate to that research software has revolutionized research environments, especially for people and small research institute like us without any big resources and personnel. The changes are happening too fast and outcomes are becoming very effective. However, when I saw the theme without reading onward, I first thought the communities meant the local communities. Like, how are we empowering our local community that's not researchers through these research software? Today, I would like to present how Matai aims to empower both communities, the research kind and the local. Let me show you some examples. So start with the research community empowerment. I'm going to use my mild traumatic brain injury, MTBI case study. Concussion is a part of the spectrum of the mild traumatic brain injury. It's a wider concept that even captures the subconcussive cumulative impacts that you might have heard from sports games and other things. This is the first study that Multi undertook when we opened, and therefore it's a bit of a flagship thing. There are many other great research going on at Multi. You can check out at our website. But since I'm personally involved in this research, I thought I could share a bit more details about things. Let's start with a definition. So what is an MTBI? Like, according to the National Institute of Health, it's a most complex injury of the most complex organ. That's quite a claim. An invisible injury, because it's something that happens inside your skull that hasn't been breached open. To me, it's a brain bruising. You just can't see how bad the bruising is, where the bruising is. Is the bruising getting actually better and resolved, or is it just separating into 7 different colors in your next 3 months, 6 months, and are there symptoms associated with it? So why is MTBI important? Due to its accidental nature, it can happen to everyone. And New Zealand has a particularly large risk cohort that covers all age span. It's called ROPI. And all injuries, whether ROPI or accidental, can be very different. This manifests as a spectrum of symptoms, severity, and their symptom duration. It's very heterogeneous, very different injury. It is a very subtle injury in terms of the routine clinical imaging that you're not really able to see much from a CT or even from a routine clinical MRI scan. So it's hard to get an objective biomarker of, hey, you are concussed, don't come back to rugby field until you're resolved thing. If you don't know the injury is current or you have resolved, it's hard to plan a targeted treatment plan for people as well. So hopefully this illustrates why it's an important clinical problem, but how does it matter to the research software engineers? Usually research softwares are focused on data management and processing and stuff, so let's start with the data structure. For MTBI researchers around the world, they usually collect these modalities. Our research with our partnering databases and other projects collect most of them as well. If you know a high-risk group who are voluntarily going to go into intense activities, you can equip them with the instrumented mouthguards and have a matching video recordings of the games to validate whether somebody was genuinely hit or not. If not, you can still collect the other modalities, such as a questionnaire of like, how badly does your head hurt? Is your neck stiff? Kind of a question. And MRI or CT imaging, microRNA, which is almost the equivalent of trying to get the COVID test version of are you concussed, yes or no. There are a few other eye tracking and genomics and even a cellular level tissue testing for having a better finite element models. But today, let's focus on what the imaging data alone looks like, because we're an imaging institute. Okay, so what does MRI imaging look like? People usually think of a black and white grayscale image, but it can be pretty. MRI is unmatched in its ability to measure soft tissue contrasts. So it can show you what your soft tissue inside the skull is doing. At the top, you have a diffusion tractography. So it shows you like white matter fiber tracks, whether they're going where they should be going, or was there any disruptions? You can track those things. And in the middle, you have a volumetry. Is your certain region volume changing over years, season, or like lifetime events? And then lastly, you can even measure the composition, the chemical composition through MR spectrometry. that might be particularly helpful to measure the tau deposits and plaques and stuff that's more of a concern towards the older concussion cohorts. MRI doesn't do just the still pictures like this. They also do dynamic pictures. It assesses the physiological functions through the dynamic analysis. At the top, you have amplified MRI, our own novel sequence from MATI. You just have a brain. Every time your heart pumps blood into your brain, it jiggles the brain just a little bit. We've artificially inflated the motion so we can see the parenchyma compliance and whether if there is any increase in intracranial pressure, is there like something diverging from a healthy motion pattern. In the middle, in the blue, you have a four-dimensional flow measurement. You can visualize and track a single heartbeat representation of blood, CSF, and venous blood, depending on how your settings are. And these are very key focus for especially the lymphatic research, how your brain gets cleansed overnight. Is that functionality disturbed if you're concussed? And lastly, the bottom left, the red blurb thing is your oxygenated blood signals for functional MRI. So these are all great tools. Conceptually, what does it mean to move these data around for processing? So these are part of our sequences that we've captured for a single person from a single session. We longitudinally follow them, and they have a minimum of like 3 sessions, sometimes even more if you've suffered from a concussion. Looking at the functional, you can see they have 10,400 DICOM files. They're small files, but the sheer number, the input-output, is just really annoying. 5,000 for a resting, 5,000 for the task MRI, and another 4,000 somewhat for the white matter fiber tractography images. All in all, this session generated 32,000 DICOMs. When I started moving them around, it was almost impossible to upload even a zipped file to, it's hard to zip to begin with, and hard to push around. If a push fails in the middle, there was no way to check some from our level, and you have to start from scratch, and it was taking a lot of time. That's when we first reached out to NZRSE and described the problem. Hey, we have this. We can't even start analyzing and looking at these data if we can't move it around to a better clusters or other more powerful computational resources, because we do not have a server room in Malta, unfortunately. They've came up with a solution that was perfect for us. They've modified the Globus delivery. It even checks the sum, and I don't have to do it. It is automatically queued, and it was beautiful. The data has been moved. Now what happens? This is a flowchart of diagram of how a diffusion sequence can be processed. You have to go from the top to the bottom to get it to the data to the stage that is ready for research. For example, that box there is just cleaning the data. For any like an inhomogeneity in magnetic field inside the MRI, just reducing the noise, just reducing. After the registration and all the tractographic performed, this process for a single file takes about 2 days. And it takes about 2 weeks to install all the related software and train up a student, even with a related engineering or coding background. So when what gets entered is something like this. This is a part of a DICOM of a diffusion sequence. And hopefully if you squint enough, maybe you will see the nose pointing up of a person. And after 2 days of painstaking time and some researcher manually waiting for an output, taking it, processing it, and getting it to the next stage in another different software, you get this. I think it's worth it. It's very beautiful. And the color kind of codes the directional information. It's not just pretty color randomly assigned. Red is front to back, blue is ear to ear, and green is head to toe. Very nice. My research don't start here. My research starts when they are all numbers. So this outputs a number array. And what I've been able to do once it reached this stage was to show how different groups, concussed or rugby or healthy, how do they differ, and snap it into meshes, match it with the different modality results from finite element simulation or a flow MRI or functional MRI, and just expand. This shows that on the left is our meshed structure of cerebrospinal tract, which controls the motor and like just how your body muscle moves. And we were able to match the most advanced voxel-wise method of doing a diffusion. But this also allows us to incorporate other modalities, not just diffusion, because we're big on multimodal comparison. For example, this small cohort from 21, we've looked at their flow and functional and additional mouthguard data. And we're hoping that we add more samples, maybe there is a clustering, and we will be able to find out what's the clustering variable. To me, at the moment, the current concussion landscape and tools used clinically looks like it's having a very bad viewing angle. And having a more modality and different tools and analytics will add a different perspective, hopefully to resolve and give some clarity and identification in an objective manner. So let's say this is our current clinical tool, asking how bad is your headache, and trying to see what animal is this? Hopefully you've all seen this domestic animal. It's quite popular in New Zealand. But to me, let alone telling if this animal is healthy or not, I struggle to identify this animal. Having an alternative, other modalities, other viewing angles, I'm hoping to see something like this. So hopefully you'll be able to have a better discernibility, which angle works well, which combination of angles work well. So these are all very promising research going in the direction of discerning, like teasing out subtleties in the concussion area. So we can investigate things together. However, in order to do this, all that data processing had to be done on our pre-existing data. So far to date, we have about 80 different unique individuals been participating on multiple years for some of them. And we're sitting at about 300 sessions of imaging data. So how do we process these things? Diffusion is not just one single process. We've processed it multiple different ways. So DKI is done, NORI is done, and many other methods. As a new methods comes up, the imaging researchers wants to run it. So how do we enable that without actually draining the imaging researchers' time sitting in front of a computer, just clicking and passing on one output file as an input to the another software? My answer was, hey, last time when I talked to NZRSE, they solved it. Let's talk to NZRSE again. So they came to rescue again. We had a wonderful consultancy, and they've recommended a workflow using SnakeMake. So now, instead of manually processing and things are batched with a very carefully controlled variables. So previously, it took 2 weeks to install all the softwares and give how to use tutorials for all students. We can actually roll this out to undergrads with no coding background, and they can run this. It's harmonized. The processing pipeline and variables being clearly set gives us assurance that analyst variability is minimum in terms of selecting different options. So this has been wonderful for students with a different background, as we are a highly multidisciplinary team. Students might come with a clinical knowledge from neuroscience and other medical research, which is a good contributor to the project, but might not necessarily be the best coder and cannot run this themselves. But through this workflow, we made it easier and deployed. So this research software absolutely empowered our own research team. We can actually make most of 10-week summer studentship, master's, and PhD. They just grab this, read the instructions, and just start turning and going through their data. NZRSE also provided us with workshop and training. They didn't just code it and just chucked it at us. So now we can actually maintain them, update if there is a new update coming on, and start working on other sequences that we want to make the workflow of. Initially, the consultation covered the diffusion and functional, and in-house, we're starting to build a workflow for the amplified. And we're hoping to keep doing this, and we're very happy to share any of these. So if there is any imaging research institute who's interested in this processing pipelines, we can talk. So outside our research team, what does it mean for our research institute? Because we have one MRI, we don't have to harmonize against the machine difference, and we do share, wherever possible, the imaging acquisition protocols. The number of slides, the resolution, and the flip angle are very, very harmonized, unless you have a strong reason for your research requirement to have a different setting. This means it's easy to adopt these SnakeMake workflow and run it on different projects. And since they're run on different projects, drug addiction results are directly comparable to our concussion results, which in again directly comparable to our healthy biobank cohorts. It's going very well for us. So we got so excited, we've extended and invited our national collaborators. So we are hoping to be able to run this pipeline on our Christchurch concussion data in a very near future. They have been collecting previously like years worth of a very similar matched imaging data. We will have to harmonize between the machine difference and other things, but once it's going, there's no data sovereignty breach, there's no ethical or legal consideration. We will just give them our processing pipeline, how to use them, they will run it, and then we can talk about what are numbers and what does that mean after. So that's not just Christchurch, we're also talking to the Dunedin cohort and Auckland cohorts, and whoever wants to use this, you're more than welcome to talk to us. Internationally, this workflow is also getting attraction because they will save operationalizing this image processing by just jumping onto this workflow. We had chats with multiple international teams and who are interested in hosting our workflow as one of their options or wanting to directly use it because they also do the interest sequence like amplified or diffusion. So there are many more, but these are the immediate collaborators internationally that we're working on, and they want to benefit from this. Okay. So hopefully I've illustrated how research software has empowered a small regional institution to be on par with the regular rigor of scientific community and make research happen. Let's talk a little bit about empowering local communities. As we do medical research, unfortunately, I cannot be separated from real people. It's not my most desired thing. I'm not a huge people person, but I sometimes wonder what it would be like to work with weather, animal, and nature data where there's no much human aspect to it. However, in this medical research, the consistent, genuine relationship is very important to draw your data from. Unfortunately, research is like a dinosaur to me. It is very slow. If you donate your data for research, unlikely you will hear about any breakthrough cancer cured the following month. We try to communicate to every donor the expected timeline and how and why it takes so much time. And they're very compassionate and understanding, which is great, but we want to keep the community along with us. Bring them so they understand a bit more process about the research and just ask us any question. And have an experience in STEM and see what we are doing. Transparency and education is what we're big on. So every year, Matai posts some summer scholarship 10 weeks, and it's aimed at local undergrad students to have some imaging. So it's offering something slightly different from their usual summer jobs offered around this region. So this year, actually last year, like last summer, we took quite a few interns. You can see them and you can read about our summer internship. We had a bunch of bright kids from across all the different backgrounds, coming from almost like an arts and science communication to computer software. All this spectrum of backgrounds, a lot of them didn't really have a personal device that can actually run and install any of imaging softwares, let alone like phone with a video camera. And you can't expect, even in Auckland, you can't expect a student to have all these research level computational processing powers and stuff. And that's when we asked NZRSE for the third time, hey, we really want to expose these students to this high level research. And is there something that we can get help from? NZRSE is like, hey, here's a project quota. We will give every intern a login, and they can actually use that snake-make that we previously did to get their own image, process them, and see what the brain structure and processing steps are like. Some of them even ended up 3D printing their own brain that they've processed through the snake-make pipeline on NZRSE. This is a kind of an ability that they would not have had access before in this region, particularly. So we were very happy and the feedback was great. So I really loved working with these interns. They were very intrigued, and a lot of them wants to come back and do a postgrad. And we have a PhD students who are doing PhD projects after doing some internship because they were intrigued by research. Not everybody has to be a researcher, but it's good to see some interest from the local community and have an option to work close to your family instead of having to go to overseas or to Auckland or other big cities. As a last part of my presentation, I would like to go back to my last year's presentation. I don't know if anybody saw that presentation, but I ambitiously promised that I wanted to have an online portal connecting the data owners to their outputs, because that's the most frequent question I get. Like, where is my data going? How is it contributing to science? What wonderful things did it contribute to? And I've realized not many research groups have that information at their tip, especially when you share the healthy databases across and stuff. You might be benefiting like 10, 20, 30 researchers around the globe if your data contributes in getting a ground truth. So through that last summer's internship cohort, I managed to sweet talk a computer science student, Ricky Noble. And he did a wonderful job in actually progressing on that portal idea. So I've borrowed his internship slide deck, and I'll just walk you through that. I think Ricky is right at the back and the left in a black t-shirt. So hopefully he had a great experience at Matai, learning how to get knowledge instead of just being fed berries. His project was to create the participant portal for data transparency, but then we have to understand that the identity cannot be incorporated into it. He's tasked to perform a stakeholder analysis, some interviews, and just get the general feeling from the real community. Just go out, talk to a few people, and see how people are feeling. Technically, you are only as fancy as the least member of community. If your grandmother participated in the research and she can only do things on her phone, that has to work. So he had these necessary skills from his background from undergrad trainings, and he wanted to deliver some portal blueprints. And he went out, and because he's a local kid, They can just go out and safely conduct hey, this is research and we want to do this, and what do you think about it? Would you like to be able to see these things? And he even drafted some examples, because people, when you just verbally talk to them, it's hard to comprehend what is being asked even. It's always good to have visual aids, anything to show to them. Image is great. A product draft, absolutely fantastic. So equipped with this, he went around and asked what the format of the app would be like, and what functionality additional to just tracking your contribution to science, what else do you want? So he opened an online questionnaire and verbally went out and asked, because we're still not a fully online community. I have to pick up a phone and call people in Gisborne to get things done and progressed, because often people will not check their emails regularly. And just had a good corridor about what the concerns, what their view, the community's view of science and research outputs are. And he fortunately got a generally great feedback about, this is a great idea. It's not a waste of your effort. And got a few comments of I would like a password. I would like it to be an app rather than a website that I have to go onto, because not many people possessed a desktop or a laptop, but they had an access to a smartphone. So he started mocking up a phone app prototypes, and that's where his 10-week ran out. In addition to this, he was doing the brain tractography processing, 3D printing, and everything. And in addition, he was also part of the leadership program and Mataranga Maori sessions and Waiata session and Whakawhanangatanga. I felt like he spent his 10 weeks very nicely. And I hope that you can see that this is an example of how research software can enrich our community, the local community, to bring them close and get them to walk with us along the research journey and ask questions and learn about each other. I would like to close with some of our research whānau team photos. This includes a lot of our key PIs and researchers and collaborators, as well as our Taumata and Namangai Maori advisory board, who are independent to us and very generously and kindly donates their time to review our research proposals and advise us, and gives us cultural training of why and what has been done and what can be fixed to be right. And we really appreciate all their help. Okay, hopefully there's some time for pad thai.
Thank you so much, Aaron. That was very, very interesting. I thought it was already a question. No, it's a comment, so I'll start with that. So Nisha say, thank you for the wonderful and reflective keynote. Kapai. Which leads me to remind people that if you want to ask a question, don't forget to go in the Q&A section of the portal. And the other thing is you can also put comments, not only questions, of course. And if you don't, I have plenty of these too. But there is already one from George who's asking you, Erin, what are the next steps for the data portal?
Cool. Kia ora. So the next step is obviously to do an internal testing, because when we talked to our other institutional partners, they were very concerned about what's the security and how to prevent hackers and stuff. And we are thinking of the answer is to not to have any personal health identifying information there to begin with. If there is no identifying information, then you can't be hacked for it. It's the same idea, like if you don't have money in your bank, you really can't be scammed, right? So we're going to try this, and we have a 12 labor project collaborator who's very interested in this in Auckland. So once we're happy with our prototype, hopefully we will get a draft tested in a more of a national level. And then we will approach other international partners if they want to be part of that registry and tracker, because our research is international.
Nice. I'd like to follow up on this by asking about, so when you were describing this online portal, there is a key word you use, and I really like that, which were the data owners. And just correct me if I'm wrong, but you're mentioning the people who went through the scans. Did the people had a sense or feeling that it were their data and that somehow they had this ownership of the data? Or how was the relationship or maybe the engagement on that topic with them?
Yeah, so actually that's a great question. We have a laminated workflow sheet every time we interact with a participant, and that starts with a greeting, because sometimes we forget. The second part is to make sure that they understand they are the data owner. They can pull this data at any point of time. And we only politely ask, once it has been processed and part of an averaged number to be reported on a written peer-reviewed journal already, we're not going to recalculate that average and remove your one data point. And they usually go yeah, okay, that's fair enough. And we do open that. And that's another key functionality. If for any reason somebody 10 years down the track I want to be removed and don't partake in further research, they should have the ability to do so. And that portal should hopefully be able to be a thing to connect to the current guardian of the data and notify them, please do not include this data point onwards from X date.
Nice.
All
very
incoming.
exciting. I'm just checking if there's more questions. No? Okay, so if you don't mind, I'll continue a little bit on this topic. So with regards to the sort of the research programs and, as you mentioned, also the community needs, can you elaborate a bit more on how you and the Meta Institute maybe globally deal with the different timescales or expectations of the difference between research and the community needs or what they expect?
Yeah. Fortunately, there are other research streams going on, not just imaging in this regional location. So they don't expect immediate outcome next year. But what we do is we offer them their raw image soon after. These are not clinical readings and they don't have any clinical significance, but here's your souvenir. This is what you own and that's what you've actually contributed. We offer them in a USB thumb drive and a web drop-off, and a lot of people choose to do a web link and have an online viewer to just look through. And I was like, I do have a brain. I had that moment too. And to them, that actually satisfies their curiosity. And during the research participation, after the scan is finished, our MR tech and other professional people can walk them and say, this is your brain. This is not your brain, kind of a thing. And we have a rigorous incidental reporting policy that we do check even before the participant pops in and stuff. And all of these are optional, as long as you want to talk. We're going to do this. And we try to do annual thank you, and this year we did this thing. And for example, our sports cohort, every year we go to their end of year prize giving and stuff, and we do a bit of a summary. And that way they feel like we're not just taking their data, running away and just abandoning them. And that's the worst thing that we don't want to do to this community, that we are appreciative again and again over time.
Nice. How is it? Oh, sorry, just checking the questions. No question. Okay, I continue. But again, you can put your question there anytime. So how easy it is to get was it set up at the beginning from the institution that you will have to engage actively, and so you can dedicate your time to go to these events, and that's sort of part of the deal from your position? Is it something you had to fight for, or it was?
There was no fight from Maltai side. It was actually encouraged from the managerial level. University, I think, is slowly supporting more and more. couple of years ago, it was really hard to put in a grant for like the Kai for like the Ahui and stuff. But nowadays, we have encouraged all our partners to put that little bit of money scurried away so you can actually feed people who come to your consultation and event at least. So it's been working. And we also, from our operations budget, we sort out the venue and anything else. That's not a problem, and it's a luxury.
Nice. Yes, and that's a very good reminder for anyone organizing an in-person event that Kai is probably the top thing to prepare for it. People will be happy if you provide food. Okay,
doesn't have to be fancy. Fancy is good, but if your budget is modest, just showing the effort that we understand their cultural practices and stuff and appreciate it might be sufficient. Because I know ECRs constantly suffer from lack of the budget problem. I know a lot of ECRs can't fly to come to like different regions and participate in Wananga and Hui as much as like the professors who have a bigger travel budgets and stuff. Yeah, so that has been a bit of a bottleneck, but yeah, we try to help as much as possible for our guests visiting Matai to facilitate that.
Apologies for my ignorance, but what ECR stands for?
Oh, sorry. Early career researchers.
Yes, of course.
Young'uns.
Okay. Okay, we have a question from Mark. Great talk, Erin. Could you describe how we can get the most out of IT and statistics people working together? Oh, nice one.
Oh, that might be more of a messy question. What can research software engineers can do for you? I might have heard that statisticians are counted as a quarrel because they don't agree with each other. So I think first step is to detail out what kind of a statistical IT problems a statistician might have. And the research software engineers are very good at solving if the problem is very well detailed and outlined. So the first thing is to identify what problem do you have. Can you open your data in Excel? Then you might not need their help. Yeah. Hopefully that's a semi-answer. And I'm a huge advocate of outsource, ask for help, reach out. There might be something you can offer from your expertise domain. And just the talent exchange, to me, brings the community together and grow them.
Nice. We have an answer. Brilliant. On this topic of having some sort of different professional cultures having to interact to each other, I wanted to ask you, so you referred to that Matai does research with MRI, but also do clinical work. And can you tell us a bit more about, what are the constraints on the technical constraints and maybe other constraints on how to bridge the gap between these two worlds that have to work on the same machine?
There are some logistic concerns, and then there is something positive as well. So logistically, clinical scans has to be very separated from research scans for privacy and other important factors. So our building, hopefully one day you can come and visit us in person, is physically separated for the whole walkthrough. The reception to MRI is separated from the researchers. So they don't naturally get to see the researchers lounging on a beanbag and go, how lazy slobs. We like that. And when we have a research booking, we go through to and meet our research participant from the reception, and we then walk through the whole, almost a clinical walkthrough pipeline, health check, scan, and once your scan time is done, you'll get flushed out. And then you get to go to the research site to continue the non-imaging parameters of like any computerized testings or questionnaires and any other follow-up chats. So logistically, we have established a good flow, and we're actually we're helping out the hospital right now. Hospital is going through an MRI upgrade, so they are not able to scan any MRI for 6 weeks. So we have offered to take that 6 week. So our clinical team is like working around the clock to digest that MRI work list. And the researchers are doing our bit and not booking any research if it's not urgent in the next few weeks. So it does work. And the beauty of it is we get to tap into the clinicians directly. The clinicians are not coders, research software engineers. They sometimes don't know what can be done for them. Sometimes it can be a very simple Excel macro that make their world and cut hours from their processing time. As simple as that. Sometimes it's a bit more complicated. That's when I pass things to the next expert. But having their insight from the front line, and they always ask very different, very good questions. What does that mean? Yes, it's cool that you can see all different colors, but what does that mean for my patient? N of 1. Because at the end of the day, research has to make an impact for N of 1 to an individual.
Wow, I think that's a very good word that you use, impact, and I love that's songs to my ears. You mentioned RSEs a couple of times. Again, anyone has any question, don't hesitate. Otherwise, I'll just keep going. Although we're ending soon, so I cannot go forever. As you were talking about RSEs, I wanted to ask you a bit more about how you feel about the RSE community in your scientific community. And what I mean by that is yourself and your colleagues. Do you see yourself as RSEs, or is the career path known by your colleagues? How is this community perceived by your peers and yourself?
Fortunately, I've been bounced between different disciplines. So the engineering community that I originally come from are vaguely aware of the RSEs. The operational researchers, definitely, but there's only a handful of them. I think the majority of the mechanical and other civil might not even know what an RSE is unless they go to concrete research postgrad. And even then, do they need things? And medical and health science, this is a totally new concept. They don't even know these things exist. They keep the cathode ray tube monitors because it works. So yeah, it's a totally different requirement field. A medical field will not move until it's 120% tested and proved that it will work reliably every single time. So to me, RSE is a very research realm, and there's a bit of a disjoint. Through Matai, I've seen, I don't know what other collaborations are outside Matai. Hopefully there are tons. Through Matai, we had the surgeons, the clinicians approach us, and I want to do this research because that has been paining me. And can you guys take on that research? And that's where we really want to hear more of. We want to be driven not by the grant regulation and stuff. We want to be driven by the community need, the real need to be addressed.
But
Did that answer your question?
Yeah. And as part of this, as you're mentioning, as part of these grants, are people aware that they will need software engineering support from the start, or is there a bit you need to do a bit more of outreach or explaining to people yeah, you want to do this analysis, but this is the amount of engineering work you need to do to get there? If you have these discussions, how do they go usually?
The way I recommend RSE to the medical field people is yes, this is great, and just show them the facts. You've spent 1 hour for this thing to work, and you had to manually click, and if you were gone for a coffee break, that's that much delay. After whatever consultation and this, you can actually automate this, make it flow, and over the years, you can have more coffee breaks. just like a car salesman, you have to sell it a bit, but once they go through an RSE project and have a taste of it, I now have the histology imaging researcher. She's actually programming macros on her own Excels because she just can't live without it. She doesn't want to go back to the days where she had to manually create a spreadsheet and stuff. So it's just a small examples that you can benefit them. They'll get hooked on, I hope.
That's an amazing example of upskilling. I really like that.
At a time. Just like
But do you feel that there was from your training, or maybe others people that you've seen coming to Matai, do you think that there are things that were missing, or you were already equipped, let's say, with everything you needed to know to achieve the number crunching tasks?
I know nothing. So
I would disagree on that, but yeah.
It's a delight to learn for me, but you always have to train the new generation and cater to their learning needs. And to me, like, you have to learn it for the first time at some point in your life. Nobody's born with this knowledge. So hopefully, like, I'm encouraging everybody I know to keep an eye on and what's possible through these things, upskill and train. But and this day and age, I think the AI and people are just becoming more and more familiar with the tools and other things. So hopefully it's going to increase the RSE visibility and just make the world a better place.
Wow, that's a fantastic final word. Thank you, Erin. We're about to close, so I think we'll stop here for the Q&A. Thank you, everyone, for attending this keynote. And what I'll do, because we've been encouraged to do so, is I will close with a little Waiata. And if you know it, please feel free to sing in front of your screen too. And I'm sure your colleagues will appreciate that. So let's go with it. Te aroa, te whakapono, me te rangi mari e tato tato e. Te aroa, te whakapono, me te rangi mari e tato tato e. Have a nice break, everyone.